Hi, my name is Ted Lin. I'm a staff systems application engineer for MaxLinear high-performance analog, serial, and bridges product line. Today, I'm going to introduce MaxLinear's automatic RS-485 half-duplex direction control and features. RS-485, also known as TIA-485 or EIA-485, is a standard which defines the electrical characteristics of drivers and receivers for use in serial communication systems. Due to actual usage, it can be used in either point-to-point, multi-dropped, or multi-point networks. It is widely used in a lot of different applications, such as industrial control, computer, automation systems, just to name a few. This is a typical RS-485 application circuit. The AB pins are the differential line signals to the bus. DI is the driver input, and RO being the receiving output. Note that there are two other pins, DE and RE. They play an important role in enabling or disabling the driver and receiver within. RS-485 can make half-duplex or full-duplex. Since RS-485 generally is multi-point specification, normally full-duplex is seldomly used in most applications. For designing RS-485 full-duplex application, since the transmitter and receiver path are independent, DE and RE for each RS-485 are basically fixed and doesn't require extra effort. Therefore, it should be relatively simple. However, most typical applications in RS-485 are using half-duplex. Designing RS-485 half-duplex requires a bit more attention to some details. This is a typical connection between UART and RS-485 transceiver for RS-485 half-duplex application. Notice that the key element in a half-duplex application is the RS-485 direction control output connected to the DE/RE pin of the RS-485 transceiver. This decides whether the transceiver is under transmit mode or receive mode. It needs to be properly handled to avoid data collision or data loss. This is the 16550 UART standard transmit interrupt behavior. As you can see, the interrupt is generated when TX50 is empty. In this case, there may be data still in the TSR, transmit shift register, when the interrupt is generated. One of the main challenges for using UART in a half-duplex RS-485 environment is to make sure the RS-485 transceiver does not return to receive mode until all data is transmitted. Depending on the 16550 UART standard transmit interrupt behavior, there will be chances for data being dropped from the TSR. So, how can we avoid this from happening? One possible software solution is pulling line status register bit 6 continuously to check TX50 and TSR is empty before changing the RS-485 transceiver back to receive mode. However, the trade-off will be the extra loading and efficiency of the processor. So, is there any better solution for this? Here's where MaxLinear's Auto RS-485 half-duplex direction control feature comes into play. When this feature is enabled, specific UART output pin will be used to control the RS-485 transceiver direction. When UART is idled, the RS-485 transceiver will be set to receive mode. Whenever there is data loaded into the TX50, the RS-485 transceiver will be set into transmit mode. And after all data in TX50 and the TSR is sent, then the RS-485 transceiver will return back to receive mode. The other change when the feature is enabled is the TX50 empty interrupt will be generated when both TX50 and TSR are empty. This will avoid the extra effort monitoring the TSR status. Additional to the Auto RS-485 half-duplex direction control feature, MaxLinear UART devices provide additional enhanced features for design flexibility. One of the optional features is the RS-485 direction control pin output configuration. In most MaxLinear UART devices, We utilize the RTS pin as the RS-485 direction control output. However, this may vary depending on the part number. MaxLinear also have UART devices that supports multiple configuration options. For more details, please check the application note DAN-190 or related product datasheet. Another enhanced feature is the RS-485 direction control polarity. Sometimes the output polarity might be reversed due to design or other factors, resulting in the transmit and receive mode to reverse. Specific MaxLinear devices provide flexibility to configure the output polarity via register setting, thus avoiding these kind of issues. Upon power-up, the control output of the UART can be in incorrect state until it is initialized. During this time, UART can unintentionally drive the RS-485 network, preventing other nodes from communicating. To avoid this from happening, certain MaxLinear devices also support enable RS-485 pins. This will start the auto RS-485 half-duplex direction control feature during power on, following reset. One other enhanced feature MaxLinear supports is the programmable turnaround delay. When the RS-485 half-duplex direction control feature is enabled, the control output change from TX mode to RX mode happens almost immediately. While in long-range multi-point system usage, there could be cases that the data transfer is not able to complete. The programmable turnaround delay provides the flexibility to add a range of 1 to 15 bits time delay before changing from TX mode to RX mode. This added delay could ensure the data to arrive at the intended destination over long distance. By utilizing MaxLinear's automatic RS-485 half-duplex direction control feature and all the additional enhanced features, not only makes designing RS-485 half-duplex application easier, but also more efficient. MaxLinear supports a complete portfolio for your RS-485 demands. For choosing the most suitable device or more details, please refer to the application note DAN-190 or visit www.maxlinear.com. Thank you for watching.